Okay, so moving on to part 2 of adding, subtracting rational expressions is unlike denominators. So first, before we get into unlike denominators, I want to point out the fact least common multiple. So just to quickly kind of breeze through what this says, you don't have to read all this, but multiples are, numbers that a certain value can be multiplied to make. So if you look at like multiples of 3, 3 can be multiplied to make 3, 6, 9, 12, 15, 18, 21, etc. Because, you have 3 times 1, 3 times 2, 3 times 3, 3 times 4. You can multiply 3 by something, and this is the product of that. So these are multiples of 3. Again, numbers that you can multiply, or I'm sorry, numbers that you get as a result of multiplying 3 with something. Multiples of 12 are, of course, 12, 24, 36, 48, because it's 12 times 1, 12 times 2, 12 times 3, right? So those are multiples. So least common multiple is when you look at the multiples between, 3 and 12 that we're interested in, and look at the smallest one they have in common. Now, the smallest multiple they both have in common is 12. Both of them have a common multiple of 12, and 12 is the smallest one that they have in common. So least common multiple there would be 3 and 12. If you want to look at 4 and 5, for example, here's some multiples of 4. Here's some multiples of 5. Least common multiple, the smallest one they have in common, would be 20. So remember that. That's kind of the idea of least common multiple. Let's kind of get into some of these. Let's look at this. So what is the least common multiple? The smallest non-zero number or term that is multiple of 2 or more numbers or terms. How do I find it? What about variables and exponents? Use the highest exponent given. So when it comes to exponents, we're just going to use the highest exponent given. And we'll kind of get to that a little bit in a second here. So let's just find the least common multiple for each of these pairs. So for 2 and 8, what's the least common multiple between 2 and 8? Well, multiples of 2 would be 2, 4, 6, 8, 10, 12, etc. Multiples of 8 would be 8, 16, 24, 32, etc. The least common multiple, the one they have in common, is 8. 8 is the smallest, yet common multiple they have, so the least common multiple would be 8 for that. So you can try these out for a lot of them, 3 and 7. The least common multiple for 3 and 7 would be 21. For 6 and 10, the least common multiple, I can give you a second. You can pause the video if you want to try and figure it out for yourself. The least common multiple for 6 and 10 would be 30. Because, again, 6 can be 6, 12, 18, 24, 30, etc. Whereas 10 can be 10, 20, 30, 40, etc. So 30 is the smallest one they have in common. For 2x and x squared, this is where it gets a little more interesting. So think of 2 and 1 as still, like, as far as numbers go, 2 and 1, the least common multiple there would be 2. I think that kind of goes without saying, because 1 can be multiplied to make literally anything. So the smallest one they have in common would be 2. So 2 is part of it. But for x's, remember, take the biggest exponent. So x squared is the biggest one. So x squared is our least common, or is part of our least common multiple. So 2x squared. I guess the reason is if you have x and x squared, multiples of x squared, I mean, you have x squared, but you can basically add an x to this, and you can have basically any version of it afterwards. For x, you start with x, but you can have any version of that afterwards as well. X squared, x to the third, x to the fourth, because basically you're just tacking on another x. So the smallest one they're going to have in common is basically whichever the biggest exponent was, because the smaller version will eventually get to that, and the bigger version obviously starts with that, the biggest version. So basically, long story short, just the least common multiple for variables is just the biggest exponent. Just look at the biggest exponent and keep that. So for 4x squared y to the third and 6x to the fourth y to the fifth, look at the numbers 4 and 6. The smallest common multiple they have is 12. 4 can be multiplied by 3 to make 12. 6 can be multiplied by 2 to make 12. So between 4 and 6, the least common multiple would be 12. X squared next to the fourth, so the biggest one is 4, so we're going to use x to the fourth. And then y to the third, y to the fifth. The biggest one they have in common is y to the, or not in common, but the biggest in general is y to the fifth. So we're going to use y to the fifth. So you always take just the bigger exponent. And then lastly, which gets really more interesting, is these. Now, to know what the multiples of these are, you have to actually factor them first. So the factors for x squared minus 2x minus 3 are going to be x minus 3 and x plus 1. So if you want to factor that, you can use your product and sum method, but I've went over that so much recently in previous videos that hopefully you're just able to factor that by now, and I don't have to explain that. The factors for the second one would be x minus 3 and x plus 2. So this has those factors. This one has those factors. So notice, basically, here's how it would work. They already have x minus 3 in common, so x minus 3 is part of those common factors. Now, the first one has x plus 1, but it doesn't have the x plus 2 that the other group has. Basically, you just need to combine all the ones that they don't have, so, or all the different ones together in general. So this is your least common multiple here. Is basically one of each. They already have x minus 3 in common, so that's there to be in common. This group is missing an x plus 2, so you can add an x plus 2 to it. And this other one's missing an x plus 1. So if you add an x plus 2 to this group, it'll be the same as this group with another x plus 1. So now you can see that they're both the same. So basically, it's kind of just one of each, I guess, when it comes to those binomials. But let's start looking at some actual problems for us here. It makes a little more sense, I think, when we get our hands dirty in the actual problems. So let's not ignore this. Let's go through this. To add or subtract rational expressions with unlike denominators, first find the least common multiple. Well, that will be the least common denominator, will be the least common multiple of the denominators. So remember, to find the least common multiple, you need to factor each polynomial, list the different factors. If the polynomials have common factors, use the highest power of each common factor. All right, let's get into it. So just to quickly remind you about how adding fractions work in general. You can simplify. I mean, you notice 2/6, I know simplifies into 1/3, so you can simplify. You don't have to simplify first. Sometimes it's helpful, sometimes it's not. I'm just going to do it here because I don't see a reason why I wouldn't. But remember, to add fractions together, you can only add them if they have a common denominator. So we need to figure out a common denominator for 3 and 10. So to do that, I need to find the least common multiple between 3 and 10. So least common multiple between 3 and 10 would be 30. 3 can be multiplied to make 30. 10 can be multiplied to make 30. Now, to do that, to make this denominator 30, I would have to multiply 3 by 10. 10 times 3 would make that denominator 30. But I have to multiply the 10 to both the top and bottom so I don't change the value of 1/3. It still has to be 1/3. It just has to be 1/3 with a denominator of 30. And to make the second fraction have a common denominator of 30, I need to multiply 10 by 3. 10 times 3 will make the denominator 30. But of course, I have to do that to the top as well so that I keep the value of 3/10. So my new fractions would be 10 over 30, because 10 times 1 is 10 and 10 times 3 is 30. And again, this is still 1/3. You guys can see that that is still 1/3. But it's an unsimplified version of it because it's important we get a common denominator. The other fraction would be 9 over 30. So again, I know it's unsimplified, and sometimes that's more helpful because when it's unsimplified, you can make the common denominators. If you simplify these, we already know it won't have a common denominator. So our first and primary goal is to make sure we get a common denominator first. Common denominator, then add, and then simplify. So I have my common denominator of 30, so I know my denominator is 30. And 10 plus 9 makes 19. So there's my answer. If I can simplify it, I would, but 19 over 30 doesn't reduce, doesn't simplify, so we'll leave it as 19 over 30. But you have to establish a common denominator first. Figure out the least common multiple, make both denominators match that multiple, keep up with the numerators because they have to still hold that equivalent value. And then once you have those common denominators, it's pretty straightforward. You just have to add things across, just like we did in that previous video. So let's get into rational expressions. So I'm going to factor, but I'm not necessarily going to cancel. I mean, I could, but it depends really if it's going to make my denominators be the same. So remember, my first primary goal is to have a common denominator. So I'm looking at this denominator on the left, and I know I need to factor that because I'm looking to see if I can have common factors of x plus 4. So when I factor this denominator, I'm going to keep, first let me keep the numerator the same, x minus 3 still x minus 3. But if you use product and sum and factor this, those factors will be x plus 4 and x minus 1. Because you're looking at two numbers multiplied -4 and added 3, and those would be 4 and -1. So that's the factored version of the denominator. I'm adding it with the 2x over x plus 4. Okay. So I remember, my first goal is to get a common denominator. So I already know both denominators already have an x plus 4. I don't have to worry about that. That much they have in common. But the denominator on the left has an x minus 1. And that x minus 1 isn't going away because it doesn't cancel out with anything. So I need the denominator on the right to also have this x minus 1. So I am going to multiply this denominator by x minus 1. That way, now look, see, it's got the same denominator. But I can't do that to the bottom unless I also do it to the top. So that's kind of the catch. So now, if I rewrite this, I kept this first polynomial exactly the same, or this first rational expression exactly the same, because it has the denominator I need. But the other polynomial, or the other rational expression, when I multiply that denominator by x minus 1, I get, now they're the same denominator, but I'm multiplying the top by that as well. So let me go ahead and simplify what that is, multiplying x minus 1 to 2x. So 2x times x minus 1 becomes 2x squared and minus 2x. So I've got my common denominator. So I know when I add these together, I'll have my common denominators x plus 4 over x minus 1. But now I have to add the numerators up. So remember, adding the numerators is just combining like terms. So I have 2x squared, and I don't have any other x squared terms, so I still have 2x squared. The x and the minus 2x can combine, so 1 minus 2 would be a -1 or -1x. And then I've got minus 3 to bring along with that as well. Now I do have to erase some of this because I am taking up a little bit too much space here, but so I apologize for that. You can always rewind the video if you need to. So that is pretty much my answer. The only thing I want to check is, can I factor my numerator? And if I can, will it cancel out with the x plus 4 or the x minus 1 I had in the bottom? I doubt it, but it's worth checking. So if you check and you factor this numerator, the 2x squared minus x minus 3, if you factor that, I'm looking for, so there's no shortcut here. I'm gonna just go ahead and quickly factoring this. So this would be x, 2x minus 3. This would be 2x minus 3. So you would have x plus 1, and you would have 2x minus 3 as the factors on top. So it doesn't seem like any of those are going to cancel. So you can write your answer like this, but since nothing cancels, you can just leave it like this as well. But it's worth factoring to see if anything would cancel. So just remember that. Let's try some other ones, because I think the more we do these, the more it sort of sinks in, especially the whole common denominator thing. So look at example 8. We need common denominators. So this denominator is x plus 2. I need to factor this denominator to see what those factors are. So that denominator, I still have, let me write this first one down. It's x and x plus 2, -8. But when I factor x squared minus 4, it is difference of squares. So when I factor that, that'll be x plus 2 and x minus 2 as its factors. So now I see what I'm missing. Can I make a division bar there? Okay. Now I can tell that both denominators already have an x plus 2 in common, so that's all accounted for. But the first rational expression is missing the x minus 2. This has a factor of x minus 2, and the first denominator, this denominator, needs it. So what I'm going to do, I'm going to multiply that denominator by x minus 2. That way, of course, the denominators will match. They'll be the same. But again, I can't do it to the bottom unless I also do it to the top. So writing this out, my numerator here, if I distribute and multiply that x with that x minus 2, I will have x squared, x times x squared, minus 2x. And of course, I have my common denominator, x minus 2x plus 2. And I didn't have to change the second rational expression at all because it already has that denominator. I didn't have to add anything to this denominator. I didn't have to change it at all. It is what it was originally. So x plus 2, x minus 2, and then I had the negative 8 on top. So again, I do have to erase this because it takes just so much space, but you're more than welcome to rewind the video, write it down if you need to. So I've got common denominators. So my answer when I add them up keeps that common denominator. Okay, but now I have to add my numerators. So adding my numerators together, there are no like terms. It's just going to be x squared minus 2x minus 8. So the only other thing I want to do is see if I can't factor that numerator and see if anything would cancel with it. So let's try it out. Again, apologize for having to continue erasing this. But you know what? That's what they do in college. They write stuff down, then they erase it. And then they write stuff down, then they erase it. So the numerator, let's see if I can factor it. Is there two numbers that multiply to negative 8 and add the negative 2? And I believe there are. Negative 4 and positive 2. So this factors x minus 4, x plus 2, and then x minus 2 over x plus 2. So yes, the x plus 2's end up canceling. So simplified version of my answer would be x minus 4 over x minus 2. All right, there's a lot that goes on here, but the only new thing that we're talking about is making this common denominator. So be very mindful of it. But once you have a common denominator, the whole adding thing, we've been over that. Just add your like terms, factor at the end of it, see if you can cancel anything at the end of it. But remember, your primary goal is to set up a common denominator. I'm going to do a couple more of these because they are kind of a challenge. So let me factor everything I can here, which is my denominators. So if I factor the denominator on the left, the 2x minus 2, that denominator, this is the numerator, the numerator is 3x. But I can divide a 2 out of this. Take that GCF out, leaving me with 2 and then x minus 1 inside. So this factors in the 2 and then x minus 1. My other denominator, my numerator here, 3x minus 2 doesn't factor, so it's going to stay the same for now. The 3x minus 3, that has a GCF of 3 in it as well, so I can factor that 3 out. And when I factor 3 out, that leaves me with x minus 1. So now, look at my denominators. They're kind of close, but they're not quite matching. Both of them have an x minus 1, so that's already accounted for. The denominator on the left has a 2, though. The denominator on the right has a 3. So you can think about least common multiple of 2 and 3. So basically, a quick way of thinking about this is this side doesn't have a 3, but it has a 2. This side doesn't have a 2, but it has a 3. So if we multiply a 3 to this side and multiply a 2 to this side, again, it's doing that thing. Hold on. Okay. We'll have those common denominators. So basically, a common multiple of 2 and 3 is 6. So we're going to make them 6. Now to do that, I have to multiply that denominator by 3, which means I have to multiply its numerator by 3. That'll get me a 6, x minus 1. And for the second denominator, I need to multiply it by 2. Therefore, I need to multiply the numerator by 2, because 3 times 2 will make 6, x minus 1. So my common denominator will be 6, x minus 1 for both of these. Okay. They already had the x minus 1 in common, so I didn't have to worry about that. But I needed the 3 and the 2 to match. And the only way to do that is to turn them into 6. So like I said, I multiplied this one by 3 to make it 6. So when I multiply the numerator by 3, that becomes 9x. And I need to multiply this denominator by 2 to make it 6, which means I need to multiply its numerator by 2. So I'm multiplying both of those numbers by 2, kind of like a distributing thing. So that would become 6x minus 4. So again, yes, I know there are things that simplify here. I know that there are things that factor and cancel. But we don't want to do that because we just basically undid simplifying it so that we could get a common denominator of 6x minus 1. We have to have a common denominator, and now we'll add things across. So 9x plus 6x will make 15x. Minus 4 is still there. And I don't think 15x minus 4 is going to factor into anything or cancel. So that's as good as it's going to get. So we'll leave that as my answer because that answer won't factor and simplify any more than that. All right. And then let's just do one more. Because, why not? Oops. Too many buttons pressed. All right. So example 10. So again, let's factor this denominator and see what I need. So the first polynomial, I'm not going to worry about that yet. I'm just going to copy it down. The second one, I am going to factor this numerator because I could see it's factorable. I probably shouldn't. But, well, I mean, at the very worst, I can just, At the very worst, I can just unfactor it and put it back the way it was. But I am going to factor it just because I noticed, hey, 2x plus 6, I can factor that. There's a GCF there. So let me divide those by 2. Let me factor the GCF out. So we'll see if it comes in handy. It might not, and that's okay. We might have to leave it as 2x plus 6, but it's worth trying. The denominator here, you would factor using product and sum. So you're looking for two numbers that multiply to 9 and add the 6, in which case would be 3 and 3, because 3 times 3 is 9. 3 plus 3 is 6. So that tells me the factors would be x plus 3 and x plus 3. All right. So I noticed something. This is sort of a slightly different problem, but slightly easier if you're paying attention. Now, it's good that I factored this 2x plus 6 because I can cancel out that x plus 3 with one of these. Meaning, by virtue of cancelization, if that's a word, I now have x over x plus 3 plus 2 over x plus 3. They both of these rational expressions have exactly the same denominator, and it's exactly 1x plus 3. So, by other problems, it would have seemed like I would have had to multiply, this. Why is that so much smaller all of a sudden? I don't know. It would have seemed like I'd have to multiply this by another x plus 3 so that it would match. This one having 2 and this one having 2. But thankfully, by factoring the numerator, this actually canceled with this. So I didn't have to have 2x plus 3's in the denominator. I could cancel them out, and I'd have, obviously, these two fractions that only have 1x plus 3 each, which is very nice. So when I add them up, now it's bigger all of a sudden. Look at that. X plus 3 is my common denominator, and then I'm adding x plus 2 to the numerator, so I have x plus 2 in the numerator, and it's as easy as that. That's the final answer. So sometimes, stuff like this happens, where you can cancel it out, and you don't really have to worry about a common denominator, because the common denominator sort of just falls in your lap. But, that, happens like 1 out of every 5 problems that you do, but it happens, and it's nice. So I'm going to end it here. If there's anything else, I'll add it to the next video, but this is a long enough video for adding, subtracting. I'll leave you guys to it. See you later. Bye.